Greetings everyone, my name is Mulisa Mukwevho. I am the alumni from the University of Venda and also from the University of South Africa. Our topic today is about paleoclimate. I hope you enjoy it. In our hierarchy of models, we started off with a bare rock, where we learned about the Big Bang Theory, followed by learning about the static atmosphere and the static oceans, where we learned that our Earth is not too hot or not too cold. We also learned about the moving atmosphere and the moving oceans, which gave us a clear understanding of our weather and climate. We are now coming to number 4. So by the end of this topic, we need to know, or you need to understand everything that is going on in this graph, and I am going to help you analyze this graph. So there are scientists who came up with this graph. So you can see that in our y-axis we have temperatures in degrees Celsius, and in our x-axis we have years in million years. The blue line that you see there represents temperature, whereas the pink line that you see there, you can see that in the last 3 million years, it indicates that there was a decrease in temperature, or there was a fluctuation in temperature. The 60 million years ago was during the dinosaurs era. So we might be having a lot of questions. So we are going to use what we call the climate proxies to find out how did the scientists know how the past climate conditions was like, and for us to find out how did they also know the exact date of those climatic conditions. We are going to use what we call the dating methods. We are also going to use the Milankovitch cycle to find out why is the fluctuation occurring in the last 3 million years. Before we go deep into our topic, we need to know what weather and climate is. Weather is the atmospheric conditions over a short period of time. It can be days, it can be weeks, or it can be months. Whereas climate is the atmospheric conditions over a long period of time, which can be 30 years to come. So a practical example of this is weather are clothes that you are planning to wear in the coming December workshop, HPW workshop, whereas climate are the clothes that you are planning to wear in the next 2 years of HPW workshop. Now, what is paleoclimate? Paleo means old or ancient. So paleoclimate is the climatic conditions in the geological past which are reconstructed from the direct and indirect data. Why then do we study paleoclimate? Why is it so important to study paleoclimate? We study paleoclimate because our Earth is changing, and is changing gradually, and we need to track all the changes that are currently happening or that has been happening. We also want to establish models on the paleoclimatology study. However, we also want to predict the future climatic conditions using those models that we've established. Now, the first question that we have is, how did the scientists who came up with this graph knew about the past global climates? Well, I have questions. Can we really know what the past climate was like? The answer is yes, we can. We have instrumental data that exist dating back to 170 years. So now the question is, can we really know how the temperatures were like million years ago? The answer is yes, we can, through what we call climate proxies. Now, what are climate proxies? Climate proxies are any feature or set of data that has a predictable relationship to climatic factors and can be used to indirectly measure those factors. An example of this is what we call the mercury. You can see the white instrument there. It's called the mercury, and it is a proxy which is used for the temperature. We are not really interested in the length of the mercury, but we are interested to see where the temperatures are. You can see that the temperatures are at the 20 degrees Celsius, which means that when this mercury expands to 30 degrees Celsius, it means that the temperatures are getting hotter. We have we have types of climate proxies. We have what we call the tree rings, we have what we call the ice cores, and we also have what we call the coral reefs. Now let's look into the details of these three types of the climate proxies. So the study of tree rings is called dendrochronology. So in this case, you can see in our diagram that we have tree rings. So in order for us to study the tree rings, the tree is cut vertically in order to expose the rings. So you can see that we have thin rings, we have thick rings, and we also have the dark spot, the scar there. So the thick rings indicate that it was the rainy season, and the rainy season means that it was during rainy season. It is an optimal time for the tree to grow. We also have the thick rings. The thick rings indicate that it was dry season, whereas the scar that you see there shows that it was during forest fire. So basically, number of tree rings represent the number of years that the tree has lived, right? So the second paleoclimate proxies that we have is called the ice cores. My apologies for that. So the ice cores are the vertical columns of ice, and the ice cores are the vertical columns of ice that we dig using the tool that you see there. So just with the same with the tree rings, so these ice cores have the vertical layers which represent the annual layers of the snowfall. So in these layers that you see there, we have bubbles of gases inside those layers. So the most bubble gas which is found there is the oxygen. So we have two types of oxygen isotopes, right, which is called the warm isotope and the heavy isotope. So the amount of in oxygen isotopes that are found there represent or indicate or show us the temperature, whether it was warm or whether it was cold. So the isotopes can tell us whether the temperatures were warmer or whether the temperatures were cold. Another paleoclimate proxies that we have is the coral reef. Now, what is the coral reef? The coral reefs are made up of the marine life. So water is made up of hydrogen and oxygen. And remember, we mentioned the oxygen isotopes previously, that we have warm isotope and we have heavy isotopes. So in this case, the warm isotopes which are found in the coral reef shows that it was during the hot temperatures or it was during summer, whereas the heavy isotopes shows that it was during winter or it was cold. So basically, the oxygen type which is found in the coral reefs determine the season during the formation of the coral reefs. Well, now we know how the scientists find out how the past climate was like million years ago. We know that they used climate proxies. We know that they use tree rings. We know that they use ice cores. We also know that they use coral reefs. The second question that we have from this graph is, how did the scientists know the exact dates of the climatic conditions that we see in the x-axis. So in order to answer that, we are going to look at what we call the dating methods. Well, I know you can see people who look like they are romantically involved in the picture. Do not feel scared or do not feel embarrassed if you are single. We are not going to talk about the romantic dating methods. We are going to talk about the scientific methods of dating. So do not feel bad. I'm also single, so let's focus on the scientific dating methods and not the romantic dating methods, right? So we have two types of dating methods in this case. We have the relative dating method. We also have the absolute dating method. So the relative dating method is the science of comparing events date. My apologies. Is the science of comparing events date without giving the exact or the absolute date. An example of this is the law of superposition, which are rock layers. I am going to explain to you that in the later stage. So the second method is called the absolute dating method. So the absolute dating method gives an exact or the absolute age of the specific event. An example of this is what we call the radiometric dating and the radiocarbon dating. So let me give you or help you differentiate these two dating methods. You can see when we have kids, when we have a boy, when we have two girls, in terms of relative dating, the relative dating does not really give the specific age. In relative dating, we can say that, okay, the other girl is younger, whereas the other girl is older. Whereas in absolute dating, we can say that, okay, the other girl is 5 years old and the other girl is 10 years old, where we are given the absolute or the exact specific age or specific age or the absolute age. So you can see the difference there. So in relative dating, when it comes to the rock layers, we can see that the layers that are at the bottom are the oldest rock layers, whereas the layers that are at the top are the youngest rock layers. Whereas in absolute dating, we can really say that the oldest layer, which are at the bottom, are 150 million years. And then the layers which are at the top have been there for 120 million years. So we are going to use the radiocarbon dating as an example of an isotopic absolute dating. So how is radiocarbon dating done? Radiocarbon dating is done through measuring the decay of an object to determine its specific age. Its specific age using the radioactive isotope of carbon. So the radiocarbon dating revolves around the unusual property of radioisotopes, which is called the radioactive decay. In order for us to understand this, we need to know what carbon-14 is. So carbon-14 is a carbon atom which is defined by the number of protons 12 with the extra neutrons to make it heavier 2 times the normal carbon atom. So in our diagram there, you can see that the cosmic rays from the sun generate thermal neutrons. So the thermal neutrons knock off the nitrogen atoms to form what we call the carbon atoms. So trees absorb that carbon-14 atoms, and the animals will eat some of the grasses which contain the carbon-14 atom, which means the animal will also have carbon-14 atom in their body. So in this case, or for you to understand this, carbon-14 atom has a half-life which is 5,730 years. So those carbon 14 atom is absorbed by the plant and is also absorbed by the animal. So the carbon 14 atom which is found in the animal when it's dead, or which is found in the plant when it's dead, is the clock which tell us exactly how long ago a sample was buried. So now we can recap back to our graph. We know that the first question that we have is how did the scientists know how the past climate were like, where we used climate proxies. We also know as to how did the scientists know how the years in million ways, how did they find out these years here on the x-axis. We know that they used what we call the relative dating and the absolute dating. Now the third question that we have from this topic is, why is the fluctuation occurring in the last 3 million years? You can see that the temperatures from the 3 million years or to 60 million years, you can see that they are higher compared to the temperatures in the 3 million years until presently. Now the question is, why is the fluctuation occurring in the last 3 million years? Well, in order for us to answer this, we are going to look at what we call the Milankovitch cycle. There is a man by the name of Milankovitch, who is a mathematician man from Serbia. His theories state that climate changes naturally due to the movement of the earth, and it is not only the anthropogenic activities that are causing the climate to change. So in this case, the earth or the climate changes naturally without any alteration. So Milankovitch produced 3 Milankovitch cycles. The first one is eccentricity. So in you can see there on our graph, we have eccentricity, we have obliquity, which is also called the tilt. We also have the precision. So in eccentricity, Earth orbits around the sun, and the shape in which the Earth orbits around the sun changes from the circular shape to electric shape. You can see there in our graph. So there are times where the Earth is far away from the sun, and there are times where the Earth is closer to the sun. So when the Earth is far away from the sun, it means that we have colder temperatures when the Earth is far away from the sun, and we have colder my apologies for that. It means that when the Earth is closer to the sun, we have warmer temperatures, whereas when the Earth is far away from the sun, we have colder temperatures. So this cycle takes about 100,000 years. The second cycle that we have is obliquity, or the tilt. So in this case, the Earth is tilted at an angle, and then the extent at which the angle is tilted changes, as you can see there. This is the case where you find that the north hemisphere receive a cooler solar energy, whereas the southern hemisphere receive the warmer solar energy. So the third cycle that we have is the is the precision cycle. So in precision cycle, Earth wobbles over its top for over 23 years, and this cycle determines seasonal difference. This is the video of what I was explaining in the past slide. As you can see, the obliquity, the eccentricity, and also the precision. So in our summary, we know that for scientists, we know that PROXIES tell us how the past climate was, and we also know that for the scientists to know the years in the x-axis, they use what we call the dating methods. They use relative and absolute dating. We also know that the Milankovitch cycle explained the variation of temperatures from 3 million years until now, and from 3 million years dating back to 60 million years. I would also like to tell you why South Africa is special in terms of paleoclimate. Well, we have fossils or remains at the West Coastal or Fossil Park, which is found in the Western Peak, in the Western Cape. So this fossil date back to 5,200,000 million years ago, which date back to 5.2 million years ago. So in order to find out why the temperatures dropped exactly at 3 million years ago, you will have to find out on the next topic of evolution. Thank you.